Hi everybody and welcome back. Our next problem says, the potential maps for BeH₂, H2, and HCl are shown below. And we have this little diagram with these potential maps in sort of rainbow colors. For BeH₂, we have this molecule where you have red on either end, shading to orange, and then a band of green, and then the central blue band, with the molecule labeled with the hydrogens on the outside and the beryllium on the inside. And then we have two dipole moment arrows shown, going from the beryllium to the outer hydrogens on either side. We see there's a color code shown to let us know what these colors mean. That says red, orange, yellow, green, blue. With on the red side, it says most negative electrostatic potential attracted to positive charge. And on the blue side, most positive electrostatic potential attracted to negative charge. Then in the middle, we have the atom H2, which is just a green, solid green oval. And then on the right, we have HCl, which looks sort of like an Easter egg. On the H side is a smaller blue side, and then a band of green, band of orange, and a larger end of red. We have three questions here. Number 1, identify the polar compound or compounds. Number 2, justify why BeH₂ has the largest hydrogen. And number 3, identify the compound with the hydrogen that will have the most attraction to a negative charge. So for the polar compounds, we look for a compound that overall has electrons in more on one direction than the other and the molecule as a whole. So the middle compound, H2, is pretty easily identifiable as nonpolar because we have two identical atoms sharing the electrons equally. So we'll put sharing equally, there's no dipole moment, and it's nonpolar. But we have another nonpolar molecule, and that's BeH₂. So even though we have our hydrogens in this case being more electronegative than beryllium, so we have these two dipole moments going from beryllium to hydrogen. The two dipole moments in this molecule cancel each other out. So two equal dipole moments in opposite direction. So overall, this means that this is a nonpolar molecule. So our only polar molecule here is HCl, since it has an overall dipole moment towards that electronegative chlorine. So that's question 1. Then number 2 says why BeH₂ has the largest hydrogen. Well, here size indicates how much electron density a particular atom has. In BeH₂, the hydrogens are more electronegative than the beryllium. So those electrons will spend more time on the hydrogens than they will on the beryllium. Whereas in HCl, the chlorine is more electronegative. The electrons spend more time with the chlorine. So BeH₂ has the largest hydrogen because the hydrogen atoms are more electronegative than the beryllium in the center, and therefore those hydrogens have greater electron density. As opposed to the hydrogen in HCl, we'll put H in HCl has lower electron density. Sorry, I just had to move that. That was going off the screen there. So again, there's the hydrogen atoms overall spend more time around, or excuse me, the electrons spend more time around the hydrogen atoms in BeH₂ than in HCl. So we'll put H atoms are more electronegative than beryllium, so it has greater electron density. Now let's turn to number 3. Identify the compound with the hydrogen that will have the most attraction to a negative charge. So the most positive hydrogen, and that will belong to hydrogen chloride. Because the chlorine being more electronegative than hydrogen, the chlorine will have a partial negative charge, while the hydrogen has a partial positive charge. In the case of BeH₂, the hydrogen has a partial negative charge, since it's more electronegative than beryllium. So the HCl will have the hydrogen with the most attraction to a negative charge, since it carries a partial positive charge. So once again, for number 1, the polar compound is HCl. Number 2, BeH₂ is the largest hydrogen because the hydrogens in BeH₂ all have greater electron density around them. And then for number 3, the compound with the hydrogen with the most attractive to a negative charge, we have HCl. See you in the next video.